This is a video from section 5.4 on indefinite integrals. I want to first start off this video by giving you a list of indefinite integrals that you will encounter. Number 1, the integral of x to the n dx. This is equal to 1 over n plus 1 x to the n plus 1 plus c. So basically when you add the c, you're looking for a family of functions so that when you take the derivative, you get x to the n back. Okay? Number 2. And by the way, on number 1, n cannot be -1 because if n is -1, you divide by 0. The integral of e to the x dx is e to the x plus c. Number 3, the integral of sine x dx. And remember, you got to think backwards. You're trying to think of a function whose derivative is sine x. So I'm going to write this down first. I'm going to say cosine x plus c. But I want you to think about how I'm thinking about it. If I look at the derivative of cosine x, by the way, c is constant, okay? The derivative of cosine x is negative sine x. So I'm like, So I notice if I put a negative sign on there, I'm going to get sine of x back. So the integral of sine x dx is negative cosine x plus c. Number 4, the integral of cosine x dx is sine of x plus c. So you want to be thinking backwards. The derivative of what produces cosine x? And so what gets filled in here is sine x. Number 5, the integral of secant squared x dx is tangent x plus c. Number 6, the integral of cosecant squared x dx is negative, begins with c, so it's negative cotangent x plus c. Number 7, the integral of secant x tangent x dx. So the derivative of secant x is secant x tangent x. So the integral of secant x tangent x dx is secant x plus c. The integral of cosecant x cotangent x dx is negative cosecant x plus c. Number 9, the integral, and this is a really, really useful one that comes up all the time. The integral of 1 over x squared plus 1 dx is the arctangent of x plus c. That one, number 9, comes up a lot. And that's one I would absolutely know, okay? We're going to go over a few more. Number 10, the integral of 1 over square root of 1 minus x squared dx is the inverse sine of x plus c. Number 11, the integral of the hyperbolic sine of x dx. Now, this is the hyperbolic cosine x plus c. And number 12, the integral of hyperbolic cosine x dx is hyperbolic sine x plus c. Okay. the more you know, the better off you are, okay? I know, and I do realize I've listed 12, but again, the more you know, the better off. 13 comes up a lot as well. If I want the integral of 1 over x dx, this one comes up a lot. You get the natural log of x in absolute value plus c. Now, generally speaking, okay, I want to give you a very useful one. If I have f prime of x divided by f of x dx, this one's very useful, okay? Here you're going to get natural log of the absolute value of f of x plus c. Okay, that one is not listed in your book, interestingly, in this section, but I think it's important. Okay, a couple more. The integral of b to the x dx is b to the x divided by natural log of b plus c. That one will make more sense in section 5.5. And then the last one I want to go over with you guys is the integral of, I'm going to do this one, k dx. Now I'm going to pull that k out in front, and then you're taking the integral of 1 dx. K is constant. The function whose derivative is 1 is x. So this should be kx plus c. And that's the last one I want to go over. And then from here, what we're going to do is some examples. Okay. So what we're going to do is we're going to find the general indefinite integral let me add an E. Okay, what makes it indefinite? Because if you look at all this list, notice how there's no limits. That makes it an indefinite integral, okay? So let's go ahead and take a look at example 1. Suppose I give you the integral of 5 plus 2 square root of x dx. Now, your instructor might have you do this. We're going to break up that integral into the integral of 5 dx plus the integral of 2. Now, instead of writing square root of x, I'm going to write x to the 1/2 dx. So I'm going to pull that 2 out in front. And so I'm going to get the integral of 5 dx plus twice the integral of x to the 1/2 dx. Now, the integral of 5 dx is 5x. And then over here, I'm going to get 2x to the 1/2 plus 1. But I'm going to divide by 1/2 plus 1. You can't forget to add that c. Forget the c, forget some points. Okay? So over here, we get 5x plus 2x to the 3/2 over 3/2 plus c. And so the answer is 5x plus 4/3 x to the 3/2 plus c. These take a lot of practice, and they do take getting used to. Okay, but that's the answer to the first one. Let's take a look at a second example. Suppose we had the integral of x plus cosine x dx. And so this is the integral of x dx plus the integral of cosine x dx. And then we're done. The integral, that's a degree 1. So it's going to be 1/2 x squared plus the function whose derivative is cosine x, that's sine x. And then you just add a c at the end. That's it. Example 3. Suppose I had the integral of the cube root of x plus 1 over, we'll do this one, plus 1 over the cube root of x dx. So I'm going to write this as the integral of x to the third plus, if you don't mind, x to the negative 1/3 dx. So this is x to the 1/3 dx plus the integral of x to the negative 1/3 dx. So I'm going to add 1 to the exponent. So this is x to the 1/3 plus 1 divided by 1/3 plus 1 plus x to the negative 1/3 plus 1 divided by negative 1/3 plus 1 plus c. Now, 1/3 plus 1 is 4/3, right? So I'm going to move, here, let's write it this way. This is x to the 4/3 divided by 4/3 plus x to the 2/3 divided by 2/3 plus c. So remember, negative 1/3 plus 1 is 2/3. Okay? And then you don't want to leave them as fractions, so we're going to pull them up. And you get 3/4 x to the 4/3 plus 3/2 x to the 2/3 plus c. And that's how you would do example 3. Example 4. Suppose I had this. The integral of u to the 6 minus 2u to the 5th minus u cubed plus 2/3 du. So I'm going to break off the integral. So I'm going to get u to the 6 du. I'm going to pull the 2 out in front of the integral and take the integral of u to the 5th du, right? Minus the integral of u cubed du plus the integral of 2/3 du. So you're just taking the integral of each of the pieces. And so this is 1/7 u to the 7th, right? Minus 2 times 1 over 6 u to the 6 minus 1 over 4 u to the 4th plus 2/3 u plus c. But 2 times 1 over 6 is 1 over 3. So this is equal to the following. 1/7 u to the 7th minus 1/3 u to the 6th minus 1/4 u to the 4th plus 2/3 u plus c. So if you notice, I'm just taking the integral of each of the pieces and just putting them together. That's literally all I'm doing. Okay. If we take a look at example 5, so we're going to do 2 more for this video. So we have x squared plus 1 plus 1 over x squared plus 1 dx. So this is the integral of x squared dx plus the integral of 1 dx plus the integral of 1 over x squared plus 1 dx. And this is going to come from familiarity with that list of integrals that I gave you at the beginning of this video. So it's going to be very important to know that list because I'm able to integrate each of these. So here I get 1/3 x cubed. That's the integral of x squared plus x. That's the function whose derivative is 1 plus our tangent of x plus c. And that's the answer to example 5. Up here is the answer to example 4, by the way. All right. Then let's do one last one. We'll call this example 6. And that was it, by the way. Suppose I had the integral of 2 plus 3 to the x dx. So that's the integral of 2 dx plus the integral of 3 to the x dx. And remember, this is a generic video. I do break up the integral before we do it, right? And so here, the integral of 2 dx is 2x. Remember, that's the function, right? 2x is the function whose derivative is 2. Okay, so let's just write 2x. And then I get 3 to the x over natural log of 3 plus c. And that'll conclude this video for section 5.4. We did 6 examples on the indefinite integral, and I give you a list of indefinite integrals at the beginning of this video. Okay, thank you.